floating point numbers that just happened to be the results of a bunch of unimaginable amounts of text going through them. These models take input, turn them into tokens, turn those tokens into embeddings, do whatever the hell CUDA does, and then gets you new tokens out the other end. Those tokens usually happen to correlate to words. There's hundreds of models out there, but if you're in luck, you should try but if you're in doubt or don't know where to start, you should try Facebook's Llama series of models. DeepSeek V3, or maybe even one of OpenAI's models. They're usually good enough to start out with. Next, you have the inference engine. This is the thing that actually runs the model. There's a few options on the market for inference engines, but usually you use something like Llama, Llama CPP, or whatever the heck they do in Python. And you'll have an OpenAI API client that hooks into the inference engine, and you mostly treat it as a black box. But this is the part that needs the GPU to run and the expensive part. When you pay OpenAI or DeepSeek for access to a model, the part they host is the model and the inference engine. Now we get to your code. Your code is going to be the thing that sits in the middle, wrapping the front end around the AI model, and doing whatever square peg, round hole you need from the input format of the AI stuff to the output format the AI returns, and sending it off to the next layer. This is the part that's the most diverse and opinionated, so I'm going to cover it the least. And finally, there's the sparkle emoji button. This is the chat box that pops up when a user clicks on that sparkle emoji button, the tool that summarizes the meeting transcripts for action notes or whatever your CEO thinks he wants. And that's it. This is all the moving parts. The AI models get run by the inference engine, your code calls the inference engine, and then presents the results to the UI. It's basically the same thing as a database in the standard 3-tier web app architecture. When you get started, you'll see a setup like this. The example code that you're cloning from GitHub will almost certainly call OpenAI's API, pass the input and context there, maybe spin in a loop to handle tool calls depending on how it's set up. It'll have a UI that kind of looks like ChatGPT's UI because that's the hello world of AI stuff. You pay per million tokens. Like, let's be real for a second. This is probably good enough for most production workloads. Like, especially where confidentiality doesn't matter and you're not having to do excessive acronym compliance. OpenAI's SRE team is really on the ball, and it's super easy to set up. Like, all you need is a core card as an API key. It works on any laptop or server with an internet connection, which in 99.9% of cases is all of them. It's easy to think about and easy to compartmentalize. You get access to some of the best models on the market, and it works out. Depending on how you use the model, what model you use, the phase of the moon, and other innumerable things, you probably will pay like $1,000 a month on the way far edge of the bell curve. You have to do some science, but that's what computers are for, right? Computer science. However, roses have thorns, and there's some pretty insidious ones that you may need to keep in mind that may make you think otherwise for this exact strategy. The biggest problem is one of the biggest advantages. You're relying on OpenAI or the other provider to keep the model up. This means you don't need to purchase GPUs or worry about uptime, but let's face it, one of the big providers being down, you're not the only one affected. But you're relying on them to keep the product functional. This is a huge position of power. They're selling almost all of the providers are selling their products at a loss to get adoption. Someday, the financial cows will come home along with massive price hikes. Like, OpenAI and other providers can and will deprecate that one model that all your production workloads hinge on. Like, this example is showing GPT-3, or certain snapshots of GPT 3.5 being replaced by other ones, and normally this shouldn't be a effective change, asterisk, but sometimes it can have massive consequences in subtle ways on your app. One time, I changed a model from one version of a model to another, and my chatbot went from, just happy and normal to a full-blown depressive episode. No, seriously. Imagine how much your app's behavior could change if, like, some key thing just goes weird. And then, they send you deprecation warning emails. Raise your hand if you actually read deprecation warning emails. For the record, 3 people raised their hand. Yeah, see, nobody reads them. Suddenly, when things get actually turned off, it's your emergency. And you get to start learning about the joys of hyperparameters or having to have the dreaded conversation of, sorry boss, sparkle emoji button's broken, it's out of our hands. Do you really want to hand over the keys to the kingdom to someone else? So, you're inevitably tempted to want to self-host all the things. After all, if the code is calling your server, deprecations are on your schedule, right? This is a nice idea. It sounds really good to the ear. Let's take a look at what the stack looks like compared to the other one. It looks basically the same, but it's a little bit different. Instead of asking OpenAI's API, you ask your own pool of GPU servers to run the model with the question and the context. The API endpoint chain transfer converts whatever you send into whatever the GPUs actually need, does whatever it does when mixing the pile of linear algebra around, and returns the results to get back to the user. The other main difference is that you're going to have to store the model somewhere because, like, a 70 billion parameter model at float 16 precision is at least 140 gigabytes of floating point numbers across n servers. That is big data. Like, officially, that is bigger data than most people's laptop RAM. That is the threshold for big data now. In practice, you'll probably end up storing your models in object storage like Tigris and then cache them to the inference servers so they load fast. But otherwise, your app shouldn't really notice or care there's another model in the equation. You'll have some semantic differences, but really you can iron them out. It's just annoying when the semantic differences happen without warning. This is a bit more complicated than relying on a third party, but the strategy has significant upsides that can make up for it in some circumstances. Biggest one, most obvious one, it's your stack. When you're calling your models on your servers, you own the stack. You get to choose what models are available. You get to choose the deprecation schedule. You get to mix and match models that will. Like, some of your app needs a model from 2 years ago. Great, you can do that. Something needs a model that was released yesterday. Assuming you have the hardware, what's stopping you? Yourself? No, what's stopping you is the amount of free time because you have to keep doing new features, eh? You also get to choose the models. You're not just limited to the ones that your provider has available. The ones that your provider, usually good enough, but what if you want to fine-tune a model for your exact use case or experiment with a new model like DeepSeek R1? What if you need to see the reasoning output in your flows? Many providers won't let you do that, but self-hosting, you can do whatever you want. Finally, the last big advantage of self-hosting is that nothing is sent to third parties. This can be very important in acronym compliance like HIPAA or GDPR. This can make self-hosting more than worth the costs in many cases, such as using AI models to analyze trends in medical records, which seems to be a pattern that people are doing for some reason. Nobody is going to even imagine allowing you to pipe all that data to OpenAI or DeepSeek, no matter what acronyms they're compliant with. Also, what if your app touches LGBTQ issues, menstruation schedules, or something that the current political zeitgeist might label wrongfitting? OpenAI or the other providers could just turn off answering questions like, I don't feel like my body is right. Is there something I can do to find out why or fix this? You'd just be out of luck. Your self-hosted models, though, would be totally unaffected. Of course, this isn't free puppies and rainbows. There's some significant downsides in self-hosting your AI workloads, and they can be subtle and kind of insidious. The big one is that the NVIDIA drivers are stable, asterisk. The NVIDIA drivers will become the bane of your existence. They're normally stable, but they can and will fall over at notice at 3 a.m. And that is the SRE witching hour. It'll never fall over during work hours, because why would it? It's always during the witching hour. You'll have to deal with the NVIDIA drivers that have no introspection into what's going on, suddenly deciding that, you know what, uptime, that's for cowards. You can work around this with worker pools and redundancy. That can change the price, considerations, everything's a trade-off. Another downside is that you have to choose what models you're using. There's so many options out there, it can be paralyzing. Like, on Hugging Face, there's probably over 1,000 different variants of Llama 2, and God knows how many models total. But like I said earlier, the Facebook Llama models are a good place to start. They're generalists, they're good at a lot of things, not really good at anything in particular, It'll get you a feel for what's possible. Eventually, you end up learning how to pick models for individual things. This is a skill you have to learn. It is learnable, but you have to learn it. Again, everything is a trade-off. Also, when you're self-hosting, you have to have opinions about how things are done. You have to choose between OLlama or Llama CPP or VLLM, or know how to use the Python stack to do whatever you want. This is fine. Like, I use OLlama for a lot of my stuff because it works well enough that I don't have to think about it, but you have to have the opinions. I had to spend the time developing the opinions. It'll work out. It's just, you have to have the opinions. But the time to have opinions doesn't really exist when the boss is breathing down your neck, wanting to show investors the sparkle emoji button. There's only one problem with self-hosting that's not as easy to work around as just having the time to have opinions. When you do this, you're going to need GPUs by NVIDIA. Like, sure, you can try other things like AMD GPUs or try running on an Apple Silicon. I can't stop you from hurting yourself. Realistically, NVIDIA cards are the path to least resistance in production. The lead time for NVIDIA GPUs is measured in months. And you can only get like single-digit numbers of them. When you do get them, they're really expensive. We're talking on the order of $40,000 per card. And you can only buy them in packs of 8 with like high-end all-yes config servers. Like, one of those servers costs like $200,000. Not to mention the fact that they need like 5 kilowatts of power at full bore. And not to mention the data center technician time to handle the hardware failure. Like, sure, you can get the cards you need off of eBay, Taobao, Alibaba, or GPU Craig on Craigslist. But sooner or later, your employees are going to run out of spare kidneys, you'll run out of budget party for all the pizza parties you make up for the kidney donations, and venture capitalists want a return on investment. Even more fun, when you do get those GPUs and you have them full bore, service life of 1 to 3 years. Then you get to start it all over again. I'm kind of amazed that anyone's able to really put up with this, but this is the kind of hidden cost of AI that they don't tell you about in the sticker price. I don't know if it's really worth it to self-host everything. I did the self-hosting flow for my chatbot, for my home lab, and it did work, but there's just one problem. NVIDIA seems dead set on making sure that consumers have like the bare minimum amount of VRAM they need to render polygons and nothing else. I wanted to experiment with bigger and bigger models, but I didn't have enough dedicated VRAM. I had to branch out into the cloud. So there's got to be some middle path between these two extremes, right? Both of these just seem like they're different types of suckitude. There is a middle path. It's called nomadic compute. This is a buzzword that I'm trying to introduce into the collective unconscious of the technology industry. Nomadic compute is cheating, but strategically cheating, and knowing exactly how and when you should cheat. It all revolves around taking advantage of user patterns and the fundamental constants of the infrastructure we're all working on top of. In a nomadic compute setup, imagine your workload hunting down the best deal between providers based on the exact requirements of that workload. You spin up more when you need them, you slay them off when you slay the excess off when you don't. It's a pretty good thing in practice, I've found. The biggest key to how this works is by taking advantage of one fundamental constant between every provider. GPUs are fungible. There's nothing really special about any one A100 compared to any other A100. The main difference is the price and the amount of video memory. Also, every cloud provider and their mom has GPUs these days. I've seen single-person VPS companies on lowendbox.com advertise NVIDIA GPUs. They're everywhere. And because there's so much competition, you can get a good deal from basically anyone. And also, from an AI standpoint, there's only 3 specifications on a GPU that actually matter. The model year, the amount of video memory, and the memory bandwidth. Every other spec on the GPU doesn't matter, because fundamentally, language models are constrained by the amount of VRAM and memory bandwidth. And the model year is a proxy for how fast the individual processors are, but that doesn't matter as much as memory bandwidth. More model year number, more faster. More VRAM amount, more bigger. More memory bandwidth, more throughput. Like, that's it. And also, you don't need the newest possible cards. My AI workflows actually use older cards that are now 3 generations old, like the NVIDIA A100. It is way more than sufficient for my needs, but because it keeps getting 1 generation older and older, the price per hour goes down. I pay less for the same experience. But if you try to make something yourself to switch between providers, you're going to look like this. All of the APIs have different corner cases. There's lots of undocumented fundamentals about every cloud provider, because why would they document how the entry point in your Docker image starts? Like, why would you need that documented? You can just figure it out, right? Luckily, though, it's the future. And there's this tool, SkyPilot. The TLDR of SkyPilot is you describe what you want, and then SkyPilot, loaded up with API keys for a bunch of different platforms, SkyPilot will figure out the best deal for you and just start it up there. You can even have an auto-scale workloads based on HTTP request pressure. So you can just sit back and let your app go viral because the infrastructure layer will just figure it out for you. So when you're trying to implement a nomadic compute setup, I wish that I could give you like a push button receive bacon example, but this is diverse enough because as much as I'd love to say that it isn't, AI stuff is all really specific to the exact use case. Like, you know, like generate text, or given this image, is it a picture of a horse? If you're trying to do this for yourself, keep these ideas in mind. Make everything as boring as you possibly can. Sure, you may want to use DynamoDB or something else that only one provider provides. No, do not do that. You have already spent all of your innovation budget on the AI. Pick super boring and battle-tested tools. Use Postgres. Use object storage. Don't use anything local, and make sure that whatever you do, you can run it anywhere with an internet connection and an NVIDIA GPU. By the way, fun fact, WireGuard lets you run it in user space. Take advantage of this. In your 3-tier web app diagrams, like I said, put your AI infrastructure in the same tier as databases. Like, really, in the 3-tier architecture, you have the front end, the back end, and the weird ancillary support services. These just so happen to usually include databases or whatever microservices you have in your cluster of fun, right? And